Okay, welcome folks. This is class number 4 and the topic is weather and climate. So this class is on YouTube for you in 3 parts. This is part 1 and then there's a part 2 which combines the Earth and space and the annual march of the seasons. And then part 3 is this part here, why does it matter for climate? Right. The handouts for today, you have them. Otherwise, they're also on our course webpage. There's a handout on weather and climate. There's a concept map, how seasons work, and then there's a graph called insolation. So why don't we just step through the differences of weather and climate? And the big picture idea here is climate is what you get. Climate is what you expect. Weather is what you get. So that really summarizes it beautifully. Now let's look at a little bit more detail. So the study of climate we call climatology. And climate is simply if you take weather conditions and average them over a long period of time. Usually we consider about 30 years here as a long period of time. And in the United States, we have a federal agency called the National Climatic Data Center, and they're in charge of monitoring and archiving and analyzing the climate of the United States. And as part of that, they're also interested in climate change and the causes of climate change, whether they're natural, human, or whatever. So that's climate. Now let's look at weather. Now, weather, a good definition here, is a snapshot of the atmospheric conditions. So if you want to see weather, you just have to look outside the window. Whatever's going on outside as you speak is weather, the state of the atmosphere at a given time and place. We have a federal agency in the United States called the National Weather Service. They're in charge of weather prediction. But there's also a lot of commercial companies in this business. The Weather Channel, local TV station, there's bazillions of smartphone apps as well. And the idea here is that weather prediction is an important thing. We like to predict the weather as accurately as possible for society to be safe, right? So the study of weather is meteorology, and meteorology is really the physics of the atmosphere. So if you want to study meteorology, you often have to go to a physics department. So for example, at UMass Amherst, the meteorology classes are taught out of the physics department, right? So let's look at this a little bit more in detail. Climate, once again, this is something you'd be interested in knowing if you were to decide, for example, to move to Chicago for a job or for graduate school, right? So the way we like to look at climate is with something called a climograph. And this is a graph where we plot month on the x-axis, and then we have 2 y-axes. One y-axis is for monthly precipitation, shown here in the red bars. And then the other y-axis is for mean monthly temperature, shown here in blue. So here you can see what the climate is like in Chicago. So you can see that the winters are cold, the summers are warm, and it pretty much rains or snows all month out of the year. So that's the information you would like to know if you happen to go to Chicago for a year, 2, 3, or 4, right? Now that doesn't mean that any given June or any given November, that's exactly going to be the temperature or that's exactly going to be the precipitation. Because remember, climate is what you expect, weather is what you actually get. So if you happen to go to Chicago, for example, let's say for a conference or a job interview, what you were interested in is the weather conditions. What is it going to look like outside today or tomorrow? That's what you're interested in. It'll tell you whether you should bring an umbrella, whether you should bring a jacket, or that sort of stuff. If you're going to Chicago for a day or 2, the climate of Chicago isn't all that interesting. What's important is the weather in the next day or 2, right? So that's the big difference. Climate is really expected weather. When you go to a place, you can expect a certain situation, and that's climate. But what you're going to get once you get there, that's weather. So let's look at what we're dealing with. Boston, Massachusetts. This is the climate of New England, right? In New England, here we're looking at the climograph of Boston. we have a strong annual cycle in air temperature. That's the black symbols here, right? And we know that we have warm summers and cold winter, and that's because we get more sunshine in the summer and less sunshine in the winter. And we'll cover that in great detail in the next few classes. What we don't have is what we call an annual cycle in precipitation. You can see that pretty much every month out of the year we receive precipitation, and more or less the same amount of precipitation, right? We do not really have a dry season here in New England. Contrast that, for example, with a tropical climate. Here we have Hawaii. See, in Hawaii, for example, it doesn't matter what day or what month of the year it is. It's always the same temperature. There is no annual cycle in air temperature in Hawaii or in the tropics in general. However, if you look at precipitation, there is a strong annual cycle in precipitation. The dry season in Hawaii is June, July, and September. So that's the time of the year that most people would want to go to Hawaii because it's warm, right? And it happens to be fairly dry. So again, New England, Massachusetts, strong annual cycle in air temperature, warm summers, cold winters, but no dry season. Here's a few more climographs, right? Here's Hawaii again, we looked at that. Here's Boston, so we know that. Now here's an extreme situation. This is Fairbanks, Alaska, right? We have an extreme annual cycle in air temperature. In Fairbanks, in Alaska, it's actually quite warm and comfortable in the summer, but it's absolutely brutally cold in the winter. Precipitation is pretty much constant all year round, but at very low levels. It's a very dry place. Alaska does not get a lot of precipitation. And here we have Miami, Florida, a fairly modest annual cycle in air temperature, but a very strong annual cycle in precipitation. That's why January, February, and December are the nicest months to go to Florida, because that's the dry season. It doesn't rain that much, and it's actually a little bit cooler than the hot and humid summer month of June, July, and August. That also defines the main climate zones on the planet. And the main climate zones on the planet are the tropics, the mid-latitudes, and the polar regions of the planet. So let's look at those for just a second, right? Let's look at the mid-latitudes here. That's us. Let's say North America, the United States, or take Europe, take Germany, take parts of Russia. The mid-latitudes of the northern hemisphere, but of course also the mid-latitudes of the southern hemisphere. Think South Africa, think Australia, New Zealand, parts of that. These areas all have warm summers and cold winters, and pretty much rain or snow all the time. There really is no dry season. Right? The tropics, we looked at Hawaii. So we're looking at this part of the world. Think Hawaii, think Brazil, think tropical rainforest. It's warm all year round. There's really no change in temperature. And it is wet. Think of India, places like that. But very often in the tropics, you have a very pronounced dry season. And then we have the polar regions of the world. Polar regions of the northern hemisphere. Here you can think of Alaska, northern Canada, Greenland, northern Sweden, Siberia. Or you can think of the polar regions of the southern hemisphere, which is basically Antarctica. It's warm in the summer, it's wicked cold in the winter, and it's pretty much cold enough that you get snow all the time. There's really no dry season. Now in the Arctic, in Alaska, it does rain in the summer because it is warm enough in the summer for rain. But pretty much otherwise, it's all a matter of frozen precipitation because it's too cold. Now that's an interesting story, because that basic climate classification system, that basic climate zonation of Earth was already known to the Greeks over 2,000 years ago. They already knew that there were the tropics, which they called the torrid parts of the Earth. They already knew that there were the mid-latitudes, the temperate parts of the Earth. And they already knew that there were the polar regions, which they called the frigid parts of the world. And they already knew that the climate zones exist exactly the same way in the northern and the southern hemisphere. And how did they know that? Right? Remember, the Greeks were living here, they'd never been to the tropics per se. They'd never been to Africa. They'd never been to Australia. Heck, they didn't even know that those places existed. They'd never been to Greenland. But they already knew the size and the shape of the Earth. And they also knew basic astronomy. And by knowing that the Earth is a sphere and the Earth is rotating around the sun, you can figure out the basic climate zones of the planet. Right? So the basic way it sets itself up on Earth with the tropics, the mid-latitudes and the polar regions is simply due to the Earth orbiting around the sun, tilted at an angle, and the Earth being a sphere. That's a fascinating story, really, because we can explain a lot what goes on with climate just by basic geometry, Earth being a sphere, and very, very basic astronomy that the Earth is orbiting around the sun. And we'll dig into that in part 2 and part 3 of this lecture. All right? So just to recap, here's New England climate. Warm summers, cold winters. No dry season. No wet season. Here's New England weather. This is a weather map. Changes every few days or so. Comes mainly from the west. We'll talk about that. And is very much predictable. And we'll talk about that as well. All right? So that's the differences between climate and weather. Here's a few weather maps to illustrate that. Here happens to be the 24th of January 2010. Here's the 25th, the 26th, and the 27th. And you can see the storm system here, which is this big red L. It's traveling across the country. And as it travels across the country, the weather here in western Massachusetts changes. And we'll talk a lot about these things. These are called storm systems or mid-latitude cyclones. And we're going to talk a lot in the next few weeks about why the weather comes from west to east and why weather is actually predictable. For now, we'll end with this. Climate is expected weather, or you can simply say it this way. Weather is what you get. Climate is what you expect. And here's a little cartoon that might illustrate this very nicely. So there you go. This is the end of part 1. We talked about climate versus weather. In part 2, we're going to talk about the Earth orbiting around the sun and the annual march of the seasons. So I'll see you back in part 2.